This metal ring looks harmless. It costs less than a dinner for two. But when it failed inside an industrial gearbox, the entire production line stopped. Within hours, the losses were counted in millions. And the failure started with a crack thinner than a human hair. It didn't start with smoke. It didn't start with alarms. It started with a slight vibration. Operators noticed a low humming noise. Temperature looked normal. Oil level was fine. No warning lights. Production continued. Inside the bearing, damage was already spreading. Every rotating machine depends on bearings. They support shafts. They keep gears aligned. They reduce friction. All of the load of a rotating shaft is transferred through tiny contact areas between hardened steel surfaces. In these microscopic zones, the pressure can exceed 2,000 megapascals. That is higher than the pressure inside a hydraulic press, and it happens millions of times per hour. Bearings survive this because the load is distributed and protected by a thin film of lubricant, but only if conditions stay within limits. In this case, the gearbox experienced repeated peak loads during heavy operation. Not extreme overload, just slightly above design conditions. But bearing life does not decrease slowly. It decreases exponentially. A moderate load increase can cut expected lifetime nearly in half. Inside the raceway, microscopic cracks formed beneath the surface. They were invisible. They grew with every rotation. After millions of cycles, small fragments of material broke away. This is called spalling. Now the damage accelerated. Metal particles contaminated the lubricant, clearance inside the bearing increased, vibration rose. Still no alarms, because the damage was internal. As surface damage expanded, the rolling elements no longer moved smoothly. Friction increased, heat built up. The protective lubricant film began to collapse locally. More heat created thinner lubrication. Thinner lubrication created more metal contact. A feedback loop. Within hours, temperature spiked. The bearing started to seize. When it finally locked, the gearbox stopped instantly. Torque transfer broke. Gear teeth experienced shock loading. The housing absorbed forces it was never designed to handle. The production line shut down. In automotive manufacturing, a single day of downtime can cost millions of euros, all caused by a component smaller than your palm. The failure remained hidden because no visible cracks, no oil leak, no early temperature spike, no fault codes. Subsurface fatigue does not show itself until damage reaches the surface. Without continuous vibration monitoring or particle analysis, early detection is almost impossible, and many systems still operate without advanced condition monitoring. This failure was not dramatic. It was gradual. It followed the laws of material science. Modern machinery operates close to physical limits, when load increases slightly, when lubrication degrades slightly, when alignment shifts slightly, the safety margin disappears, and the system pays the price. The gearbox did not fail in one moment. It failed over millions of microscopic stress cycles, one crack at a time, hidden beneath polished steel, small component, massive consequences. This is how machines really fail.